I think that we can begin. Federico, the stage is yours.
Okay, thank you, everybody. Today we're going to be talking about something quite interesting. Why? Because it essentially was built in a pretty short time, less than 3 weeks. And it also showcased how important and how fast the landscape of coding and programming in general and software development in general is moving. So what I will be talking about today is about how to use RavenDB GenAI in combination with MCP servers to perform really advanced asset intelligence. And I'm saying asset here because anything that has a digital footprint is susceptible for this type of work. So without further ado, what we're going to be is starting with once upon a time, we used to write every single character of code by hand in the IDE, of course. That's what we do, programmers. And in the same way that almost nobody writes assembler code, even though I do, soon almost nobody will write anything resembling a formal language, like a programming language, to actually do the work. And I don't know, I know this is a kind of a bold statement, I get it. But my last month has actually convinced me that is not far from truth, even though, you know, we're still in the pretty early stages. So my advice here, just to start, is contemplate the price you are paying for inaction, because what you are doing is you're not deciding if AI shapes the world by saying, no, I'm not going to be involved in this. You're just deciding whether you are going to matter in that world or not. So you can fight that. I don't think it's a good idea. That's a personal opinion. So at RavenDB, based on this realization, what we did about it. First, we started with where everybody started with this introducing vector search, which actually is the usual thing that any provider, database provider could do, is providing vector search. But we didn't stop there. We moved farther into the generative AI at the database level. It's with how do we allow generative AI to become part of a process inside the databases, managed by the database itself. But this opened a very, very interesting idea, which is like, if we can teach the database, the GenAI, the LLMs to actually interact with the data in a structured fashion, can we actually teach that same AI or agents to actually use our code? It's like our code is available for everyone to use and to see in GitHub. So the question was like, okay, let's figure out if it's possible to actually teach agents to actually use our code. That immediately leads into, okay, so if we could actually teach agents to use our code, can we actually develop code directly using agents with minimal programmer involvement in that? And when you read that stage, you are going to start thinking, hey, you know, now I know where the AI usually fails. Can I actually develop tools to help agents? And that essentially happened on a very, very short timeline. But so let's move forward. So we do all of that. So we do the generative AI. We are actually teaching agents to understand our code. We are actually developing code with those agents so we can understand how to develop tools to help those agents. But the end idea of this is so you don't have to. Okay, so the idea is to play this game so that we are able to provide you this ability as a user. So at the level of the generative AI, you already have seen the Jan in the last episode to actually show how this can be done and how easy, how can you actually create very interesting queries. Today, what we are going to be talking about is the other three, which is how did we teach agents to use our code, which is interesting because you can actually replicate this knowledge into your own code. How to develop code using agents to help you in the process, which you also can replicate if you do the first step on your own code. And in our case, you can actually see what we do to help our agents to actually build better code for us, which you can also actually reproduce on your side also. So let's think of this more like a blueprint concept in which we are going to talk about today. What's the actual recipe to actually being able to accomplish this kind of thing? So from the point of view of teaching agents how to use our code base, the very first step that we introduced was actually improve code readability, which is also a goal for humans. We have been doing this for years already. Why? Because essentially our code is very, very big. So whenever you write something and you have to remember that you wrote it 8 years from now, it happened to me, like I've been touching code recently that is roughly 10 years old. So I actually have to think what I was thinking when I did this. This is important for you, for your future you. It's important for your teammates, but it actually becomes very important for your agents. And there's a reason why, which is pretty state-of-the-art research, recent research, which shows that language structure is actually pretty bad for agents. It's like you can have the same code, and if you go to the code and just change the variable names for something that doesn't make any sense, and the function names and everything, the structure of the code, what it does is the same, but the agent is not being able to process it. However, when you annotate the code, when you pay forward your future to 5 years from now, when you have to actually go and touch the code, it's actually also pretty good for agents. So it's like we started on a pretty good baseline because, you know, we already have that because we have been building this annotated code over the years to actually help us to arrive to better solutions. The next thing was actually provide clear rules for agents. For anyone that is interested in that, you can actually go to the source and look for agents MD files and on the different directories, and you will see exactly the type of rules that we give agents that are going to be inspecting our code base, so they are able to operate correctly along the way. And there's another thing in which we started pretty well is in like test, lots of tests. And just to give you an idea, we have roughly over 10K tests, 10,000 tests that test every single aspect of the database. And for us, it's pretty important because we have good coverage. But for the agent, is good because it actually can figure out how the product, how the different code is being used. We also introduced like 5 years ago a categorization of tests where we can actually tell that there's a human whenever you go and write a test, you actually say, okay, this test is actually testing patching functionality or indexing or low-level Boron or any particular thing that involves the database, even the client API. So all this information is actually pretty useful for agents, and they get a great source of examples, and also provide agents clear path to navigating and interacting. For instance, if you go to the root agents MD, we're going to tell, okay, this directory has this directory has that, this other project is about this, and this other project is about that. That also gives the agents the ability to navigate and interact with the code in a much more streamlined fashion. But as I mentioned, it's like, okay, we were more or less in a good situation. So you actually go and build those agents and these MD files. But is this enough to actually go and develop code using agents? Well, it just happened that the very first task that we tackled was like saying, okay, we have 4,500 tests that were missing categorization. And the reason why they're missing categorization is because they existed before the categorization. There was actually more than 6K, I think, at the time. And the rule was, if you ever had to touch a test, then you have to categorize it by hand. So let's say that we had roughly 3K or 4K tests already categorized by humans. So what we did is like, okay, let's see how good we can get. So we started with a very, very small sample of them, and we just go and refine the rules for categorization. And that essentially end up with a series of pull requests that my friend here, Pavel, suffered through, in which essentially we recategorized everything. We even let the AI to actually recategorize some things that it thought it was not correct, and then we checked them. I checked them personally, that they were correct. So essentially, the AI in 5 days was able to do something that we were not able to achieve in 5 years, okay? Because like, put someone to categorize 4,500 tests, and they're going to resign by the next week. So, but it doesn't stop them. So when you go to like finding defects or proposing improvements, I work in performance. Like, I look at the assembler code. Like, I did some tensor operations, and I needed to figure out how to make something faster. I just put in there, I wanted it, the annotated assembler. It just happened to tell me, hey, you know, you're not using this. Oh, really? I just went to use that, and I get 30% improvement for tensor operations, which is awesome. So the same, we were able to, like, we had problems between two different regression between two different versions. Just get a diff between the two. Tell me where it's more probable. This is this is your idea number one. This is what I already tried. It didn't work. Let's go to idea number two. It just happened to be that the case. Okay, so these kind of things, it actually happen even though it's not visible for the outsiders. Like, for instance, an entire GenAI support, disabling, enabling thinking mode, whatever, that was entirely built by AI. But the point of not telling that PR was entirely built by AI was actually figured out it was able to pass the PR review, and it did. So you see this and you say, okay, yes, great. Now, you also then see this. This is the kind of things that you will find on the news. It's like saying, no, agents will fail because they fail 70% of the time. Yeah, because agents depend on how you use them and on what you use them. This is the part, the important part about this. So I'm going to tell you what we did right, or what we found that it works, which is probably going to be interesting for you. Essentially, the very first step for me is like, for our case, was like, actually make it write tests. And you have to look at the test like a hawk. It's like, the AIs are going to try to game the reward function, which is passing tests. So essentially, that the only thing that you have to really control is the test that it writes. because it will try to game them just to pass the test, like avoiding testing something or whatever, because it cannot fix it, okay? Also, interrupt immediately the agent when you notice something is off and correct course. Why? Because the ripple effect that those errors cost you are insane. Another interesting thing is when you are actually working with this in a fast fashion, is like, oh, I have multiple copies of the project and I'm working on features in parallel, and actually that's pretty good. Technical debt. This is a talk for everyone. It's like we were used to like say, okay, I'm going to fix this like this because it makes sense, because I don't have enough time to actually fix it. Technical debt with agents is radioactive. It's like either you get rid of it very fast, or you are going to get technical debt on entire code base. Because if there's something that the agents do pretty good is in replicate patterns. If they find the technical debt, they are going to replicate it along the way. Another thing is focusing on the small features. It's like everybody say, hey, it didn't work. Why? Because I asked it to build a game like this and like that, and it couldn't, and it was not able in one shot. Now it doesn't work. Okay, that's not how you have to think. You have to think it in terms of, okay, I need to fix this. For needing to fix this, I need to do this, and that. Okay, let's start with this one. Which is essentially how you work. It's like nobody just goes and right from the get-go, I'm going to building this, and you build it from top to bottom. So essentially what you do is like, okay, I'm going to tackle this, then I'm going to tackle, that doesn't change. That's essentially how programmers work. You have to include yourself in that workflow. And also think about this. Think about the agents like junior guys. It's like, okay, if you have to explain to someone that is not senior on your code base, what you do, you can just go through the code and tell, okay, yes, don't do this, do that. Don't do this, do that. Don't do this, do that. Which is like essentially how everything works. What you can do is actually leave notes on the code, and then to handle all the to-do list, and it will do it. And because it now has the context of the entire things that you changed, now it's much better to replicate those patterns. But the key thing here is don't expect to replace humans. It's the wrong approach. The human in the loop is essentially for this type of work. And we actually have to get used to include the human in the loops in such a way that we essentially don't become the bottleneck. And I have a talk, you can actually pull it up from YouTube, speaking about specifically that particular problem. So in the concept of development tools to help agents, I think that the proper way to face it is like develop tools to help agents do a better job. Okay, because I can say from experience, and you will see it in a few minutes, I can actually be able to do a very, very good job, very, very fast, but they still need a lot of guidance. Okay, so you still need to be the programmer. So this is very, very recent research. So this research acted in the following concept. Say, okay, can we improve agents through search? Like, if I provide the agent the key piece of information that the agent needs, can I actually get better results? And the response to that is a close to unanimous yes, at least for coding. Okay, as you can see here, like you can get a very, very small a small model like StarCoder 2 with 7 billion parameters, which is pretty small. And you can push it from 31.7 to 94.5 in human eval, which is one of those benchmarks. Or you can get on the more complex one, like open domain, you can get it from 14.6 to 17.5. Like, if you think about this, Those are non-thinking models, very, very small. So it's pretty reasonable that the most difficult ones do not work so good, that you don't get that much increases in performance. But there is a key piece here, which is the right context will more often than not get you the right outputs, okay? Given an advanced enough model. And that's one thing that we know so far, is that as of today, we're still getting better models along the way. So it's like just a question of when it's going to be, that model is going to be good enough for the problem that I have to tackle, okay? And if not, you can supplement that knowledge with your knowledge to actually tackle the problem, okay? You are the right context in this context. So in the process, we are actually talking about MCP, Model Context Protocol, which was designed by Anthropic to actually interact with different services. And it essentially became the de facto standard that was adopted by everyone. You can think of it like a generalized interface to talk with AI agents. They're pretty easy to build. I'm going to show you how easy it is to build it, but they are also pretty hard to get right. Why? Because you're essentially creating a conversational interface to your AI. You can actually go and look at the technicalities of this. Like there's many people talking about that, so it's pretty uninteresting from the point of view of this talk. But on the other side, for the three important things for us in here, it is supported 3 types of assets. One is pre-baked prompt. It's like, okay, I have this prompt to do this thing in a standardized way, so you can actually create your MCPs that gives you prompts for specific actions, which you know that they are going to be working well with your particular problem or service. You have resources, which are things that are there that you can the agent can request to actually, hey, you know, the agents MD files are like susceptible to be put there in the resources. Like these are the rules. So the very first thing that it will do is it will get a manifest of the resources, and they will find rules. Okay, this makes this may be interesting. And the most important for us is the actual tools. Okay, so things that you can ask this service to actually do, and that means that the agent itself has to know not only how to call it, what it does. So you have to expose this information, and the protocol itself allows you to expose this information so that the LLMs are able to use them. So from now on, we are going to be talking about something that we build in a way to demonstrate the power of semantic search and GenAI capabilities of RavenDB, but because it actually makes sense for us to build that for us. Okay, so without further ado, what we are going to be talking about is a service without RavenDB code intelligence, which essentially exploits GenAI pipelines to analyze code. So we take code, we pass it through our GenAI pipelines to extract information that is then being interesting and usable by vector search, to semantically encode it and access it in a way that whenever the agent needs something interesting on a big code base, or not so big, it doesn't matter, it actually can pinpoint exactly where to go. For that, we use a state-of-the-art intelligence search algorithm, SATL. If you want to look at it, it's probably roughly less than 1 month old. So the idea in this search architecture is that you have the usual keyword. No AI in this case, we have AI anyway, because essentially what we are doing is we are generating metadata through AI, but not semantically encoded by like the straight grep-like interface. We also have vector, which is semantic, and the intelligent search mode, which is the SQL algorithm. On the other side, it also tracks files interconnected through dependency graph. The better your dependency graph, the better your results. So this is pretty boilerplate, but it's important for anyone that has been working in searching and understanding, okay, how do I search it? How do I query this information? And the other interesting thing is that it combines traditional full text search with semantic search, which is probably the biggest. This is the intelligent search algorithm, which is the biggest, more interesting departure. With integration with model context protocol, the AI can access this information, and it does summarization and categorization during indexing, which is an entirely different thing. So let's start with a demo, okay? So what I'm going to show you now is I'm in the RavenDB code analyzer, okay? So I'm going to instance Cloud Code. And I'm going to ask it, I built, and I'm going to show you the command later. I built a demo that I said, okay, show me, explain the Raven code MCP to the live audience here. Okay, so what is going to happen here is that it's going to be connecting to this service that is running, and it's going to be discovering essentially what this MCP is doing by reading that manifest that I talked about the resources and the tools and everything. So in this process, it's actually going to be calling. You see it here. I'm going to stop it here so you can actually see that RavenDB code intelligence analyze code is calling contexts. It wants to see what contexts are available in this system. So with that, it has discovered that there are 13,000 indexed files and a massive RavenDB database engine. Okay, this is the RavenDB source code. So it's going to start asking information about the things that it finds, and it actually finds that, okay, server, the MCP server, it's written in TypeScript. Okay, so it will look for references to the search tools, which are the actual tools. By the way, and the important thing about this, all of this that is happening is not written anywhere. So that I will show you. I will show you the demo code, so you actually see how important that is. Essentially, I'm not telling in everywhere that we are going to be there's any reference to what this MCP server actually does. It's just telling you, okay, yes, you should be able to explain to everybody what it is. So it can see that there's a system architecture where the MCP server runs on a Node.js process, which is also true, and it's been hosted here, which is also true. So it's now trying to understand the microarchitecture, how this MCP server is built, because it has the context. And I didn't even actually give it information about what I was actually looking for. Because I could actually say, hey, go to the knowledge base, which is one of the things that I have indexed, and tell me how the model context protocol work, and it's going to look at that particular code. Or I can ask something about the specific, AI integration on the RavenDB code for this same demonstration. In this case, I just let it go and show you the impact on what it is happening behind the scenes, so it's actually able to understand, to give you an idea of what it looked for. Okay, so this is like entirely free flow. So just to give you an idea here, the hours of manual code exploration actually become seconds of intelligent search, which is true because you're essentially seeing. There's also fragmented knowledge across teams, yes, but you have a truth, a ground truth, which is the entire software. So this is the unified intelligence that isn't in the files. It's there. This is your product. This is essentially all the information that it matters. In this case, it's telling you about exactly what is going on and etc. But just to give you another idea. So now I'm going to be opening two different instances in our. This is RavenDB code, which means that I can give access to I can give access to Claude specifically to access this code, right? So let's look at this. This is the RavenDB Intelligence MCP server, okay? So it has tools. So one is search, one is get content, and the other one is analyze code, which is pretty straightforward. So in search, this is the manifest. This is how the MCP server knows what it is doing, and the Cloud Code knows what this MCP server is doing. These are the parameters, and the parameters actually have information, so it's actually been able to use it. Okay. So what this does is essentially showing you that there's nothing here that actually can generate the information that I show you. Okay. So what I'm going to tell this agent is say, okay, now this is an actual problem. Find all instances across the entire RavenDB code where async await patterns are used in conjunction with document transformation operations. I'm specifically looking for MapReduce index definitions that handle both field transformation and concurrent transaction processing. In this case, use the RavenDB Code Intelligence MCP on the RavenDB 7.1 context and intelligence search, okay? So this is kind of the things that I, as a RavenDB developer, may be asking somewhere around trying to solve something. On the other hand, what I'm doing here is not allowing to use RavenDB Code Intelligence to this other instance. This instance is going to be using the file system. This other instance is going to be using the MCP. Okay, so this is the kind of thing that you shouldn't do live because you don't know how it's going to end, but I'm doing it anyway. So as you see here, it's looking into the different into the different code using different type of accesses. In this case, it's doing a weird search, MapReduce, whatever in an intelligent fashion. In this way, is doing grep calls with await, MapReduce, await, async await, and other glove operations. It's looking for the CS code and everything. However, in this case, you can actually see it's looking for very specific things like indexing processes, and it's getting files like MapReduce index base that for us, which is in our internal code, it's essentially where you would go if you needed to go into figure it out this. Now, can you as a human use this? This is a REST API. You can just go as a human and write, how do I get this and that? And you are going to be encoding this and accessing it. So while we let this work, as you can see, this is much more advanced. It's already finding stuff and analyzing the field transformations while this is still working. So meanwhile, while we are at this, I'm going to be opening the RavenDB instance that is powering all this. So what you have here is essentially, this is the code, okay? So let's say that we want to look into what this does. Look, here we have this one, which is still working, and this one is already in the process of analyzing. So in here, what we can see is actually saying, okay, so we have all these documents, and these documents they have this summary here, okay? I'm not a TypeScript guy, so we are going to be going to C# to actually make sense, because I'm not that good. I don't know sharding at all, so let's better focus on something that I can actually give you some ideas, which is, for instance, I don't know, fast vector highlighter. Okay, so this is the indexing code. Okay, the only thing that we actually input in here was this, which is the actual code. Okay, and for that we created a process which actually would summarize this information and create this summary and these key points. It's like, okay, so this is what this does, which is create fragments for Lucene highlighters with pre and post tags. Anyone that has been using highlighters know what this is. And it also creates then the key points, which are the or other important information that you can actually extract, which is not necessarily from the summary. In some cases, it's like this is using this particular process or whatever. And then categories, like, okay, this is lexical analysis, it's related to parsing, it's to language processes and document processes. All of this is essentially correct. The complexity of it is simple, and there are functions that are interesting and all that stuff. How this works? This works through RavenAI, GenAI tasks. In, like, for instance, let's look at the summarization. In the summarization, what we do is we have this code that is chunking, particularly because I'm using a very, very small. Let's start from here. Better. This is I'm using this through an Ollama service hosted in my machine on a 3090 with 24 gigabytes, which means that I'm not being able to run very, very advanced models. Actually, they're actually very, very crappy models, which is, in this case, is a Qwen 3 with 0.6 billion parameters. And to give you an idea, any decent model that you will find on OpenAI or whatever is over 250 billion parameters. So we are talking about a model that is less than 500 times smaller, okay? And still, they are able to get you a pretty good result, as you can see here. You can actually go and read it, but essentially, I ran this demo for me so many times that I also know what the result of it is, and it's actually pretty notable how fast this is in comparison with this one, and there's almost no difference in the response. In fact, I actually sent, without telling anyone, these two results in a blind test, and 100% actually rated the intelligence code one as better as the other one. And this is people that actually know the coding here. It was a very, very unscientific test, but it was a test nonetheless. In this case, what we have here is, like, I'm using a Ollama service. So you don't see that I am joking here. This is the Ollama running on my machine, and it's taken while doing the work. And with this small model, we were actually being able, with a very, very simple prompt, like, analyze this code file and provide a structured analysis, in which we are asking for a summary for 3 key points and a few categories and an assessment on the complexity, to just generate this data that we can use then for actual searching. Why this is important? Because if you use a better model, which is a little bit more expensive because you can actually have to rely on third parties, or you have to host more bigger models on your own infrastructure, you can get better results, okay? But still with this smoothing that I can run on a gaming machine, you still get very, very good results. And like, there's nothing different in the reference. In reference is more or less the same thing. It's like, find the six things in this file. Dependencies, export, references, types, related files, anything that resembles that is going to put it in there. And if it cannot find anything, it's going to be empty. Who cares? Because we're using this for searching. But you can do this in law documents. You can do this same thing in almost any asset that has a textual representation that you can have. It's like, we can build relationships inside code because this is exactly what we're looking, but you just go and change the prompt and the same thing would essentially generate the same thing for anyone else. And then you have like this code search index, which is actually quite complex, but it's not something that you haven't seen yourself in your own developments. It's like a simple project of this into and in this case some calculations that I do to implement the intelligent search. But that's it. It's like you're asking a index to get you the actual data. So the code is pretty straightforward. And with that, what you're actually seeing is how search and AI agents can actually generate a lot of good things, because you can access all this information directly. You don't even need anymore to actually work directly with the code in question. Like this demo that you have seen here, it was entirely built with just Cloud Code, a diff viewer, and Git, and no ID. Why? Because the idea was to show that was possible. Okay, it's like if I would have used an IDE, I would probably even finish it even faster. And just to give you a hint of how big the thing is, we're talking about 70,000 lines of code, 135 files, 194 tests, 62 commits over the span of 2.5 weeks. It's okay. 3 days. I actually hit the limit of the 100,000, 100 bucks plan for cloud. But it's because I actually pushed the limit. The cost estimate of a senior dev is I actually did. I look at the code and say, how much time? 2 to 3 months. Then I ask O3 and Grok, and they all more or less have the same code. It took me 2 weeks and a half to build this entire thing. So let's say you want to build a server, the MCP, okay? This is the type of thing that I actually use, but there's a but. There's something here. It says use the MCP, the code intelligence. And the reason why this is important is this. I indexed for my work. I've been dogfooding this tool with myself. It's like to build a knowledge base. What is a knowledge base? A knowledge base is source code that I actually believe it's good quality. Okay, so I can actually use as a starting point for someone. So what I put in here, I essentially put the TypeScript SDK. So now the cloud have access to this information, to how to build with the SDK, and also example MCP servers. So what it means to you, what it means to you having good reference code, it means that you can actually point the AI agents into the kind of code that you like, and you feel confident to say they are high quality, and use that to actually translate those patterns that it finds in those codes into your own project. Okay. So the question is, if I ask how much time it would take to build this, in this case, it was three things. It's like I'm automating the usage of a RavenDB, instance. It's like listing the databases, list the indexes, and get the database stats. It took 20 minutes with a prompt like this. It's like this is the extraction of the actual prompt after the fact. What this was able to do, it was able to do to actually have a fully function, and this is after it finished testing all the endpoints and all the endpoints works using Echo. And then say, show me the databases. These are the actual databases. Show me what this index does. So it goes to Raven, gets the indexes, and it's telling you. And because it have access to the file, it actually knows this is from this project itself. But then you go and look at this, okay? So you can actually ask the statistics. Typical things that you would use a studio for, now you can actually go and ask. Why you can actually go and ask? Because essentially you have an NCP that allows you to do that, okay? This is a proof of concept, but the point stays. It's like you can build your own NCP for almost anything that you want to have access to, as long as it has a REST API or somehow you are able to connect to it. So with that, I am open to questions. Like we have 10 more minutes. So Gracian, you open if you have anyone's questions.
I'm just looking at the chat, but I don't see any questions. Let me check on YouTube too, because we are live streaming that. So there will be recording available if you want to watch it later. On YouTube are no questions, but I have questions myself. How much does it cost? Because you know, I've seen that in the Cloud Code when we were running this on the terminal, you know, the tokens go sky high, right? You do just burning like a couple of thousands of tokens. So how much does it calculate it to?
Okay. This is to me it's a very interesting topic because I've seen being asked this a lot. It's not like you're not the first one. I should have known that. There's a very important distinction here. On one side, you have like Cloud Code. Cloud Code is going to be using tokens. Those tokens, you either have a particular you're just routing them to your own instance, you're paying money for them, or you just get yourself a subscription. I am pretty sure I didn't do the calculation, but from the days that I actually kill it, like I was able to max out the 100 subscription. If I could have used tokens, I'll probably have having to spend 3 times that in a single day. So subscriptions, at least for Cloud Code, they seems to be like very, very subsidized. So if you're going to be using Cloud Code in particular, just go with the subscription because that's how you get it. You can get a lot of mileage with the 20 bucks. I actually hit the limit very fast, but I was doing this, but I was building this. So it's like expected that it happened because I was pushing it a lot. But I think that for most people, the 20 bucks is okay. If you move into if you hit consistently the limit, like I did for 2 days, you just have to move into the 100. But I mostly haven't hit too much the limit for that one either. So like, and I was testing stuff. I was not only coding, but testing these particular sequences of what I was going to show, understand what the limits were. Like I was burning tokens like crazy. Now, on the other side, would you tell me if I'm going to index RavenDB for production, I could do it with OpenAI. But for my internal use case, which is here, with that 0.6 billion model is more than enough, okay? So that would depend. Like I download something from internet, so some sample code that I think, oh, this is interesting. I'm not going to be using OpenAI for service to actually index that. I'm probably going to use 0.6, even if it takes me 20-30 minutes to index using AI techniques. Okay.
Okay, so for actual daily job, it's not that costful. Like you really push that, right?
Yeah, I really push that.
All right. So yeah, so I see that there is no more questions. So I think we're gonna wrap it up. So Federico, I'm very glad to have you with us today because the thing you just showed is absolutely brilliant and open-minded on actual AI usage. So there were a lot of absolutely great insights, like dropping the human bottleneck in order to augment developer, not skipping humans from the loop. So the thing that you made it so fast is so inspiring. So I think that I'm gonna try Cloud Code myself. Being honest with you.
That's the idea. That's the idea. Really, it's very. I think this is a personal appreciation after being in this process. It's like if you figure out that your typical workflow as a senior developer, like if you're a senior, this is what happens with the senior thinking. Is like I have to actually relearn the process. There's like the workflow is entirely different. Those things that I put in the cheat sheet, I had to develop them over time to actually figure out, okay, yes, this is how it should be done. It's not like that. When you actually do that, when you actually realize that there's a big difference in how you used to think and in how you have to think for using this type of technology, then it clicks to you. And when it clicks, it's actually it's like an entirely different development experience. And that alone, and the speed at which you can actually prototype and take risks is insane. Because sometimes you could say, if it takes to me 4 hours to actually do this refactoring, which touches like 10-15 files, and you can actually now explain pretty well what you want to do. I want to do this, and that. It's like, it's not a lot. It's not very complex. You can just spawn an agent to do it. And because you have your test, so you can actually test and ensure that, hey, it keeps working. You can actually take much, like I redesigned the commands infrastructure for the command line 3 times. I didn't care. I wasted tokens like crazy, yes, but I didn't care. And this is, to me, what it actually makes a lot of sense is like you can take certain risky decisions to see how that would look, which you otherwise would never do if you are working toward the deadline. Okay, so you can continue working on the path that you were, but you can actually spawn an exploratory path, which is probably crazy at the time, but then you figure out, hey, it actually makes sense, but you didn't do it. You just guide the AI to actually do that and to show you the broad idea. Then it will come to you to the decision to actually, okay, I'm going to take this direction or I'm going to take this other direction based on the results.
Yeah, makes sense. Absolutely. Exploring all the possibilities, because for all of us, I suppose that's a kind of new approach to write code, right? So yeah, to explore is very good decision. So but I think that watching how experts like you play with that can really simplify and ease the process of learning that, right?
Essentially, as like I was not built in a vacuum either. It's like in my case, I can say I started doing this task for categorization with Augment. I figured out, hey, Augment works pretty well because it has this context engine that I can prompt and tell, use the content engine. Oh, now it works better if you force it to go to the context engine. And then I moved into the Cloud Code and say, what this is missing is the context engine. This is what I built. Okay. And this is the thing, is like you start working from okay, this is what I see, this is the idea. What's the idea? The idea is if I have better context, I'm going to get better results. Okay, let's build better context for the agent. And that's how you start building. It's like I found a very, very interesting command, which is ultrathink, which spawns 4 agents to do different things. It just happened when you haven't, if you hit those loops that everybody talks about, in which it tries over and over and over and again to the same thing, it's like you're wasting token because it cannot escape that loop. The ultrathink mode would just kill it. And I got that from someone that posted it on Twitter, and I just then modified it to suit my needs. So yes, I agree. And you have to be aware that there's very, very good ideas floating around that are very, very useful. And the interesting thing is that the cost of actually trying those ideas is going down pretty fast. Because right now it's a prompt. It's like the entire ingestion pipeline started with me playing around with a recipes database by just auto tagging stuff. Or if instead of auto tagging recipes, I auto tagging code, would it work? Yes, it happened to work. I just copied the same concept with a different asset.
Right, but one last question from me. What do you think is the way that we, give the model, our domain knowledge? Because what we have seen today was like a very efficient way to transfer our domain knowledge to the AI, right? How do you think that it's gonna evolve in a few further months or years? Do you think that it is gonna be like a very emerging area that we're gonna discover a new way to how to transfer our domain knowledge to AI more properly and maybe faster?
That's a good question. And I'm saying this is like trying to predict anything that is going to happen in tech in the next 6 months is pretty tough. It's like I can say something and it's probably not going to be true because we are going to find something else and it's going to blow our minds. It's like it has been like that for anyone following this for like 2 years or 3. It has been like a pretty wild couple of years. Having said that, it's like some people is natural to this easily. The younger you are, the more natural it becomes to you. So what I foresee is that the 10 years old, 15 years old of today are going to be like making a dent into the market way earlier than we were able to. It's like they're going to start with a much higher threshold capability from the get-go. This is what I see this going. And anyone that does not realize that things are changing to the point, like I gave it as an example. I built this without even an IDE. It's like you don't need an IDE today to actually code something. And for that, that for me was like mind blowing. But how did I got that idea? I got that idea from friends that I have that are in different industries, which are not programmers, that are starting to program. And you say, how did you do this? I did this and that and that and that. What IDE did you use? What? Oh, yes. Did you use Cursor, Augment, Verb, Visual Studio, VS Code? No. I didn't use anything. Okay. So these guys were lacking what we know about source control. But they still were able to pull off things that when I was young, when I was in university studying programming, it would take me weeks just to start. And they are able to do it in like 2 or 3 days of just fiddling with the code, fiddling with the prompts, okay? Telling the AI what they don't like about it. Now, we can be very, 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 we can exploit our knowledge, but we have to start to think differently about it. I don't know if that answered the question.
Actually, the great insights are there. Yeah, sure, of course. So yeah, I see that by now there were no questions, but usually questions arise right after the event on the DevTalk chat. So be there. I think that's something gonna spawn after the event. So yeah, I think that's it. Again, very much thank you, Federico, for the great presentation. It was something absolutely extraordinary. So I hope to see you in the chat in a few days ahead, as well as everyone in the everyone with us here. And yep, hope to see you in the chat. Stay ahead, guys. See you.
See ya. Have fun.